Problem 1198 has a ski jumper, starts from the horizontal takeoff with a speed of 25 meters per second, lands on a straight landing hill that's inclined at 30 degrees. This is the hill shown here. There's the takeoff velocity there. Wants us to determine the time between takeoff and the landing, time it hits down here. The length of the jump, D, located at this distance here, and then the maximum vertical distance between the jumper and the landing hill. All right, so the givens we're given is initial y velocity is 0, initial x velocity is v naught, which is 25 meters per second. We're given theta, the incline angle. Wants us to find the time to land in the A part. So we write out that x is equal to v naught t then, which can be listed as also d cosine theta. I'm going to call that equation 1. We're going to put the y motion down. The initial y velocity is 0 and initial y position 0, so we have a minus 1/2 gt squared, and that's going to be a minus d sine theta for these dimensions we're given. If we'll take equation 1, the negative of it, and divide, negative equation 2 and divide by equation 1, you'll see that we will get right here a 1/2 gt squared divided by v naught t. That's going to leave us with a t gone, one of the t's gone, and it'll leave us g and v naught down here and a 2 down here. So we'll end up g over 2 v naught times t. And then these right here will be sine theta divided by cosine theta. D's will go away and we're left with tangent theta. You solve for time out of here and you get 2.94 seconds. For the B part, we're to find the distance d. We can go back to equation 1 right here and put in the time and solve for d, and we get 84.9 meters. Each of these numbers I'm storing in places on the calculator, so I store their unrounded off value. Now to find out the C part, trying to find the maximum height between his projection, and we're just going to assume some position out here, and I'm going to call h then the maximum height that we're after. So you can see that we can write tangent of theta as this distance right here, which is your negative of your y position here, plus h. And there's the h minus y. Minus y is because the y value is negative right here. And then divided by x position right there. So tangent theta can be written as h minus y over x. Or h then is equal to y plus x tangent theta. And y is minus 1/2 gt squared for the time it takes to get right there. And then you got x is v naught t, and so you have this expression right here. So now we have h as a function of time. We can take the derivative, first derivative here, and when we do, we'll get minus gt plus v naught tangent theta. And when we set that equal to 0 and solve for time, we'll get v naught tan theta divided by g, which if you'll notice, that is half of the time that you had right here. Right? Take the second derivative here and you get minus g, which implies then that time that you solve for right here represents a maximum. And so you go back to your equation here and put in that time and simplify things down, and your expression simplifies to this right here with an answer of 10.62 when you plug in your numbers.